Hello, and welcome to StreamFest. We're Blue Robotics. We're live from our headquarters in Torrance, California. I'm Jess Eason.
And I'm Tyler Buckingham.
And I'm Tony White, and we're streaming to you out of the blue.
And we really could not be more excited for this Stream Fest that we have for you. This is a 3-day festival of streams, ladies and gentlemen. So this is day one, and we have an amazing lineup prepared for you today. We're going to cover the gambit, but this is going to include everything from education all the way to industrial uses and all the wonders of the underwater world that have been captured using accessible ocean technologies. And we just could not be more excited to be sharing this with you. This has been a total team lift for us to put this together. We've gathered footage from all over the world. We have guests today from all over the world to share their amazing footage, and we just could not be more stoked.
I'm excited. I'm a marine biologist by training. I'm excited to see the critters, the ecosystems, hear about the projects, the missions. I've had the opportunity to talk to a lot of the people that we'll be hearing from today, so it'll be really great to see what they have for us, and these streams are going to be so amazing. What are you excited for, Tony?
Oh man, so much. We've had a long road at Blue Robotics. It's been really fascinating to watch the journey from the T200 thruster to the BlueROV2 and even the BlueBoat a couple years ago. We've got a lot of exciting products in our future, and seeing what people around the world make with them and what's possible when you have a modular enclosure or a modular cheap way to bring cables from wet to dry. It's really exciting. So I think the most exciting part for me, though, is just how worldwide all the efforts are and everything we're going to be talking to.
Totally, man. And for me, you know, my first introduction to marine technology was the Titanic expedition. I'm sure there are a lot of people out there that share that. And all of that technology that was used to go discover and look at Titanic was millions and millions and millions of dollars. It was like you had to be an astronaut to do that. And what's amazing is that's changed. And now regular people like you and I, can go out and explore the underwater world and collect streams like you will see today. And it's going to be awesome to share.
Yeah, so before we get started, I just want to say if you guys have any questions, please ask them in the chat. We're live on YouTube. We'll get to them as they come in. Also, this production is co-produced by our friends down in sunny San Diego, Deepwater Exploration. They're in the studio with us. We'll hear from them later this week. And without further ado, we're going to go into the blue. We're going to start with our first guest.
Diving into the blue.
Our first guest is joining us today from the Brisbane area in Australia. Welcome, Matt Dunbabin. We're so excited to have you here. I know you got the floaty boat. I know you got the coral bot. Really excited to see what we'll be talking about today.
Thank you for having me. Great to be here.
Awesome. So let's take a look at the video, the stream.
Sure. So as you mentioned, we've got the coral bots, which start off as ranger bots, and we're moving into the floaty boats. And what we do is a lot around interventions and conservation for marine protected areas. And a community level scaling of conservation. So we've developed a lot of vision-based underwater vehicles. This one was about 3 weeks ago with the University of Hawaii, using hyperspectral imagery to assess coral reef health, but also detect invasive species. And here you can see what the robots themselves are built quite small, all autonomous, and they can operate in very challenging environments. Here, even though the reef looks quite beautiful, it is incredibly stressed if it is fluorescing pretty much in daytime, and you'll see shortly that this reef has pretty much died after this heating event here.
Where is this, Matt?
That's it. That was actually on the Great Barrier Reef there. So we do a lot of work around the world, anywhere from sort of Puerto Rico, Dominican, US Virgin Islands, Maldives, Philippines, and also back here in Brisbane. So we developed systems that can collaborate. So surface vessels for very challenging, reef break areas, all have vision on board for real-time processing. But we also do things like cooperative robotics, where we have multiple vehicles simultaneously mapping an area, because you might have very limited time when you can actually get into these areas. And now some of the latest work is where we have our surface vessels deploying our small underwater vessels. And it's just some really cool stuff that we're doing with our particularly for our colleagues in Hawaii, actually, to map areas that you can't really get into with normal boats. So you can't get an ROV and you can't get, it's too long range to carry all those things over very shallow areas. So this has been some really cool work that we do here.
And operating without a tether has got to be great from a flexibility standpoint.
It is, but it adds a whole bunch of challenges. Obviously, reliability, software, any errors are due to our software. Pretty much, we can do as much harder as we can, but the environment changes as well. As you saw, they're very challenging environments. We operate very close to the reef, within probably about 1 meter, 3 to 4 feet above the seabed. So these are quite challenging, but it's been really fun to sort of work in these areas, particularly where we can have our communities actually deploy these and assess their health, but also do what we call active intervention. You saw some examples there of sort of the payloads that we can carry. So we can actually deploy baby corals. So we do areas where we do larval restoration, quite large areas, and because we all have onboard AI on our platforms, they actively choose when and when not to deploy larvae, because in certain areas it's a very precious resource. So where do you can actually make the decision on where to deploy it. We can also control pests such as crab starfish. We have an injection system that we can put on these systems. We're currently in the US Virgin Islands doing active fish tracking, so looking for spawning aggregations for fisheries management. So actually have the coral bots follow the fish to where they're spawning and aggregating. So there's a whole bunch of really cool areas where you can sort of bring together robotics, obviously building these nice small platforms. You can bring together vision and AI. They will process that, and then to do something pretty cool either individually, so either mapping or doing some sort of control activity, or collaboratively where they can scale the conservation efforts.
How does the larvae, the deployment of coral larvae work?
Yeah, so we work with colleagues from all around the world that are marine biologists. So I'm a roboticist, but we work with marine biologists, and there's a technique. So the particular area that we're doing is what they call larval restoration. That's larval restoration. So on a particular night or nights of the year, all corals will release their sperm and eggs into the water column. We collect that, we rear it for about a week in these floating pools, just till they become what they call competent. That's when they want to settle and find a spot to settle on the coral. Now, obviously, that's a numbers game in the wild, because they might drift out to sea, never find a spot where they're suitable. So once we've collected that, it's been about a week, we have a bladder that we can add to the, I think we're just about to see possibly in one of these mosaics, a bladder that we have on there. We can hold about 100 litres of concentrated coral larvae, and we've got a specialist pump that we've designed that is actually larvae friendly. They're very delicate things. And there's onboard cameras, and as it's flying over the reef or the substrate, they actually choose if it's suitable. It might be algal dominated, which is not suitable. It might be sand, which is not suitable. But if it has that Goldilocks area where we think it could be restored, we turn the pump on, release larvae, you give it the best chance of settling.
Very cool. We maybe only have a couple minutes left for this stream, but I am curious. We saw it pass by a couple times, these toefish that you're towing behind there. Is that for your photogrammetry efforts?
It is. So one of the areas we're really interested in creating these very high resolution maps. So AUVs are really good for getting down close to the seabed. Surface vehicles can only measure from the surface down. So if you have that mid range where you can't actually see, we have a toefish that can actually sort of fill in that gap, absolutely going down to about 10 meters that we do that. And if anything deeper, that's when we actually deploy the underwater vehicle with the floaty boat there, that inflatable surface vessel that you saw.
That's so awesome. It's incredible footage. Thank you so much, Matt.
My pleasure. Thank you.
Yeah, thank you so much, Matt. We're so excited to have talked to you, and you're doing such great work. I believe we have links to some of the stuff you're working on, but is there anything you want to leave us with in the last couple of seconds, or anything coming up you want people to tune in on?
No, I just appreciate the ability to be able to demonstrate what we're doing. I think, particularly with the tools that Blue Robotics have, we can be creative and develop solutions that have impact, particularly to community level robotics. Community level conservation. So I think, please see what we're doing. Look up the Queensland University Technology website, the Centre for Robotics, and you can sort of see some of the really cool stuff we're working on. Thank you.
Awesome. Thank you so much, Matt.
Thanks.
One of the things that gets me thinking about is underwater communication. You mentioned the tether off the bat, Tony. So for those who are not robotics nerds out there, you might not know that underwater it's not like an aerial drone. You need to oftentimes tether your robot, or in this case, they're using software to navigate those reefs autonomously, which is super cool.
Yeah, I would imagine that the robot is driving itself, like you said, with vision, and the surface boat is probably monitoring it via an acoustic link, or maybe an optical link. But either of those isn't enough to send video over. It's just enough to make sure everything's going okay and maybe call it home when you're all done.
Very cool. Very, very cool. And of course, there was a jellyfish that made a flyby in that video. I hope everyone saw that. That beautiful jelly. Our resident jellyfish expert here, Jess, who studied jellyfish.
Sure did.
Moon jelly.
Looks like a moon jelly. They're really common.
Are you ready to call it?
I mean, I feel pretty confident about that.
Okay, I'm gonna go with you.
I also think it's really cool though. Coral restoration stuff can be finicky work. It's not easy to seed corals. It's not easy to regrow them, especially in the wild. So he's doing really good work. The technology he's using, that he's developed around doing this work, is pretty much at the front, at the cutting edge of this research. So that was really cool to see.
Agreed.
Yeah, and hopefully that lets it scale to the point where it can be applied, many places around the world.
Absolutely.
So next up on our streams, we're going to be taking a quick look from some video from one of our forum users, 3DMB, also known as Marcus Brown. He does some exciting exploration of shipwrecks, and he's been exploring ways of using Blue Robotics hardware to do cinematography
Absolutely.
captures of those kinds of wrecks. Let's take a look.
Let's dive in. So immediately, in reviewing this one, we said freshwater.
It seems like it might be fresh water. It's definitely dark and murky.
I was like, fresh is relative, right? Like, what is...
Well, in other words, it's not salty.
Right.
And my point is that we've gone from the salty Great Barrier Reef into a fresh water body of some sort. Mystery.
Yeah. It looks like we have a plane fuselage here, I think.
Spooky. It looks really spooky. I'm a little scared, but it's really cool footage. I know that Marcus was saying he used our BlueROV2 and he was, experimenting with different cameras to get this footage. He's about to do some really cool historical filming that'll come out next year. So I know this has just been a really big project for him. He posts a lot on our forum. And our forum's a really great place just for the tech community to engage with each other. I mean, it doesn't even necessarily have to be just Blue Robotics technology. And me being fairly new to this space, I learned a lot from our forum, and it's been really great to get to know the people on there. So this work is really cool, and he does a lot of photogrammetry. And Tony, you were talking earlier about what exactly that is.
Yeah, so photogrammetry is the process of taking video or pictures of an object or a part of the bottom and turning them with a computer program into a 3D model. And that lets you take measurements and see how big things were without having to take a tape measure down there. And it also lets you compare, if you map it on a regular basis, how things are changing over time. I think we just were seeing there some kind of gun emplacement that's on the bottom, and unfortunately there were some tires around there. I would love to get them out of the ocean. It can be so bad in terms of leaching chemicals. And serving as a trap for marine life. To your point earlier though, Jess, our forum is a great place to discuss all forms of marine tech, Blue Robotics or otherwise. That's a cool anchor on the bottom.
Yeah, it looks like that anchor got beat up pretty bad, snapped and broke.
Yeah.
Cool.
You don't see that often from an anchor. Anchors are usually built
Yeah.
to take a beating.
And
What's
here we
this?
see the ROV. That was the ROV on the map. Now, normally when you're driving an ROV, you don't have an idea of where it is because radio waves don't penetrate, so you don't have GPS location.
Right, right.
But you can use other sensors, usually acoustic, to get an idea of your position. And that can help with photogrammetry a lot because if you know where you were and which direction you were looking when you take those photos, it's easier for the computer program to reconstruct.
It was also super cute. That little, the little picture was really cute.
Yeah.
I think the BlueBoat is just a really cute little piece of technology.
And here we have wood, another indication that we're in the freshwater environment, because in saltwater that would disappear pretty quick, but in the freshwater environment that can stay intact for a long time. And just a quick note, in the Great Lakes region or in areas where you're getting like mussels, like zebra mussels, it's clarifying the water because they're filter feeders, and you're actually getting a more your better visibility on these wrecks, which is kind of an interesting little unintended consequence of introducing invasive species that benefits investigating shipwrecks. But okay, let's move along. We've got another great guest to introduce here, and basically, if you know anything about Blue Robotics, you know that we're really into kelp and seaweed. We're rather obsessed, I think it's fair to say. And one of the reasons why is because there's so much potential, particularly in the regenerative aquaculture space. And so for our next guest, we are super stoked to beam in Sam Reeves. Sam works for Ocean Rainforest, one of our partners on our Grow Line initiative, which is where we explore how marine technology can be used on kelp farms. Sam, welcome.
Hello. Hi, guys.
Welcome to Streamfest, Sam.
Good to be here. Thanks for having me.
Where are you, Sam? Can you remind us where you are right now?
I'm in Santa Barbara, California right now.
Oh, I wasn't sure if you'd be out across many oceans.
No, it was up in the air. I think I'll be out in the Faroes next month, but in the US for now, which makes it easier.
Love it.
Well, Sam, we have some footage that we want to dive into that shows the farm. So let's put that up. But let's also talk a little bit about Ocean Rainforest Farm and what it is that you guys are doing up there in Santa Barbara.
Yeah, so out here in Ocean Rainforest, Ocean Rainforest is a Faroese company, which is why I'll be out there next month. And we're the US branch of it. We grow slightly different species out here to the European team. We grow Macrocystis pyrifera, or giant kelp. And our aim is to create a biostimulant out of the kelp. And the biostimulant is like a probiotic or a multivitamin for plants. And we'll be spreading that around the farms in the local area. And hopefully they can reduce the amount of artificial fertilizer they put on a farm because of our biostimulant.
Very cool.
Very cool.
Yeah, I think California is, a major breadbasket. Lots of agriculture happens here, and so a product like that could have a pretty big impact, especially if it's supplied locally, huh?
And yeah, that's our whole idea. It's a local California kelp for California soil. We grow the kelp out in California waters.
Oh, beautiful.
There's a great example of our kelp. We process it here in California and sell it to farms that are our next door neighbors. And then it's a circular system. We're taking out those artificial fertilizers on our local farms, which creates less runoff into local rivers, which means less runoff into our local seas. So yeah, it's a really local system, and that's what we're trying to promote. California kelp for California soil.
Love that. I love the sustainability angle. It's one of the most exciting elements, I think, of the regenerative aquaculture movement. And as we look at the footage here, what I see is looked like an ROV cam, Sam, diving in, and we're going down and we're doing an inspection. Could you tell us about what it is that we're doing here?
So the Blue Robotics ROV has been super essential to our operation. So as part of our agreement with the Coastal Commission, every 2 weeks we have to go out and inspect the equipment for failures and stuff like that. As you can imagine, if we were using divers every 2 weeks, that would be thousands and thousands of dollars worth of dive time. So luckily, we can use the ROV, as you can see here. And what we do, we go out to one of the buoys, fly the ROV down 30 feet, and it gets to a metal plate, which should have 5 rope connections into it. I'll take a photo with the ROV to prove to the Coastal Commission that we are looking after our farm and everything is still in place. And then I send off the report to the Coastal Commission. But
So-
this has been super vital because, as I'm sure you guys know, regulations in California are kind of crazy. And if we didn't adhere to these agreements we have with the Coastal Commission, any applications we have going forwards for a commercial site would be hindered. So having a reliable ROV every 2 weeks that we can know isn't going to fail on us, it's going to produce good quality images, has been super vital. And it's been great partnering with you guys on that.
It's been great on our end as well, Sam. We've learned a lot about your operation. And one of the things that I thought was really cool about your farm is, it's an ocean vehicle. The BlueROV2 is an ocean vehicle, and occasionally things break. And Sam, you've really dived in on the right to repair aspect of our technology. I think have you swapped out a thruster? And I know you've definitely had some maintenance that you've done yourself, which is really cool.
Yeah, it's one of the nice things about the Blue ROV. Like, you guys send it as like an adult Lego kit, which it can seem a bit daunting at first, but then when you get into it, it's a good process, and it really helps you learn how the ROV works. So then when we have had issues like a thruster got a damaged propeller, I was easily able to swap that out. They're also super customizable. You guys made up a custom hook for us to use, which we've also installed at times on the ROV to help grab loose ropes or hold the ROV in position. So yeah, that customizability and sort of hands-on experience you get from building the ROV is really good.
It's always frustrating when you can't fix something that you got. Just to touch back on the 5 lines touching there, those hold everything in place, and your farm is what, I think 80 acres? It's spread out over? We see some of the aerial footage there?
That's right. The seabed footprint is 86 acres, and then the area you see on the surface is about 16 acres. And yeah, those lines that go into the metal ring, one is an anchor, 2 are structural backbone lines, and then 1 is a cultivation line that runs perpendicular. It's like a ladder. So
I think it's coming towards us in the view there, yeah.
Yes, yeah, correct. Yeah.
Cool. Any questions, Jess? You were all fired up this morning.
I'm still fired up. You guys took a lot of my questions. I was really interested, obviously, in the biostimulant part. I think that's really cool. I think that's really different from what I know a lot of other kelp farms are using the kelp for. A lot of those are consumables or restaurant grade consumables or snacks. So I don't know, how did that come about? Like, why did you choose to have your end product be a biostimulant?
I just think it made sense for the area. There's a lot of demand for a kelp biostimulant product already in the surrounding area on the agriculture farms, but they've actually been importing it from Asia, South Africa, Ireland. And so there's a real hunger for a locally sourced biostimulant, which is what we're trying to promote. We had an open day here last week to launch our 2 products that have just been released to market. So we have those products now on local farms, and we're seeing great results with them, especially on strawberries right now.
Super exciting, Sam. Sam, Reeves, thank you so much for joining us on Streamfest. And man, they've got some really cool things going on. And this is why we did Growline. We wanted to see what we could do, how accessible ocean technology like the ROV, like other technologies like the BlueBoat, in fact. Just this morning, one of our colleagues, Larissa Zip, gave a presentation at Aquaculture Information Exchange about applications of the BlueBoat with side-scan sonar on kelp farms. So we are exploring at Blue Robotics how accessible technologies like what Sam showed there can be used on kelp farms all over the world. It's very exciting.
I love the metaphor you used before, Tyler, of farmers need to walk the field. If you're doing terrestrial farming, you walk out, you see how your crops are doing, you see what the bugs are up to. The Blue ROV2 lets you do the same underwater, and the BlueBoat lets you do the same from assessing large areas with the side scan sonar and monitoring how the biomass can increase. There's a lot of exciting research happening in that area.
I know. And Jess and I want to become kelp farmers, just like Sam.
I'm 100% committed to having a kelp farm.
We're on our way.
Yes.
Look out, Kelp America. We're coming. Now, this is a great opportunity for me to introduce our next little segment, something we're really proud of, the Watertight Box song. Enjoy.
Blue Robotics, you know you got it, that watertight proof case, perfect amount of space. It's square, not cylindrical. Don't be quick to be so critical. Well, you can mount your circuit boards on an internal tray, of course. Oh, but there is so much more. It's machine aluminum. You've had heard of 300 meters in depth. Oh, this box can handle it. There's 2 different sizes. Arduino, a raspberry inside of them. For the smaller one, if you like. 8 poles are on the sides. We got a large box for PCB. 16 holes made for wiring, with handles made for storage. And guess what? Yes, it's buoyant. The lid, it has an O-ring. Tool is designed for closing. Unscrew the locking cord. Well, inside your motherboard. Or it could be so much more. Well, lastly, mounting holes on the inside. Threaded holes on the outside. Aluminum water cooling. We're even open to different sizing. And it's gonna be exciting. This watertight box is our breakthrough. This watertight box is just for you.
Man,
What a banger.
that is a banger.
That was crazy.
It's a Blue Robotics banger.
I loved it. That was it was the eye contact for me most of all. Yeah, it was the feels and it was the eye contact.
And the pan to the box.
The
I
pan to
think
the box.
is
We love
particularly
that.
golden.
That song was by Paige Byrd. We're so honored to have him featured. And from what I hear, at our 10-year celebration last year, we were singing that song.
Yeah,
It
a
was
whole
a
bar
hit.
full of people singing along to it. Probably raised some eyebrows.
I would have just
Definitely.
joined in. It would have been fantastic. Well, that was fun, and I could not be more excited for our next guest.
The lineup continues. You know, the thing about a stream is that they flow, like this show. And we're moving right on along.
That was amazing. Thanks, Tyler. Yes, our next guest, so excited. Valentina Venturi. She's coming to us from Italy, and she's talking about her buoys, Gipsy buoys. These are amazing, amazing technology that was used in the 2024 Olympics. Tony, you got any more information on these buoys for the people?
Yeah, as far as I know, they use a couple of our T200 thrusters, maybe the M200 now with an update, and a GPS and some of their own electronics. And they hold position and allow the sailboats to have a target to race around, importantly, without having to put an anchor on the bottom. So,
Yes.
how you doing, Valentina? Great to see you.
Hi, nice to see you again, for those who I met. And yeah, thank you for inviting me. Yes, we do build robotic buoys for sports. We focused in regattas at the beginning, and now we are just spreading up a bit. We used at the beginning the 200s, 2 of them, but now after I actually visited you, we had the chance to talk to some of you guys, and we said, why not putting 4 instead of 2? So we have redundancy. We had at the time some problems with the plastic on the water, especially where the Olympics took place. So that's why we wanted a bit of redundancy, but the model now works very well. Maybe I should go from the start because some people don't know what we talk about.
Let's dive in. Let's get this stream. Well, let's undam the stream and see what flows here.
Yeah. So.
All right.
Yeah. So as a sailor, I start from the beginning. I was very bored of waiting for people to move the buoys, because in our sport, we need to have a course that is perfectly aligned with the wind, and the wind doesn't often stay at the same direction. So we need to always wait for people to go there with a rib and move manually some buoys that are anchored. And often there is a lot of depth and it takes time. So the idea came to me in 2016. There was nothing like that at the time. And since then, I just wanted to build robotic buoys. I was very focused. And after trying some solutions, I found that with your motors, this works best. And yes, we have this buoy. There is an inflatable part that is covering now a bit the motor part. You don't see it very well. But this has two tilted motors that go down in the water, so people can retract them when they take the buoy in the rib. So they don't get destroyed, basically. And our strength is just a lightweight as a feature, because as I was alone at the beginning, I really wanted something that I could deploy by myself in the water. I tried at the beginning this thruster for the fisherman boats, the trolling motors. And it was really dangerous, because once I almost fell in the water. And I'm Italian, but my company is based in Switzerland and it's very cold in winter. So since then I said, okay, either I take something light or I don't do it. So thank you for building these amazing products.
Well, thank you for using them. In such a cool and innovative way.
Yeah. So now we are not only in sailing anymore. We also have requests from rowing competitions, swimming, as you see here, some wakeboarding, some motorboating, and also aerobatics, to have some reference in the water. Just fly, straight. And
So how did the Olympics come about? How did you guys get into that? I thought that was super cool. This is a super unique way of being involved in such an amazing sporting event.
Yeah, Olympic never used robotic buoys before, and they started to, push on sustainability. We have this problem in the Mediterranean, but I guess everywhere, about Posidonias disappearing. So we know that in France, especially, they start to forbid anchoring. And in Marseille as well, there are so many restrictions, and they were a bit forced to use something more, let's say, less invasive. And so the buoys were tried by the French Federation of Sailing 2 years before. We developed a bit together, let's say, the version that then would be the Olympic ones. And we did a tender. We participated. Now there are competitors, so let's say we were very happy to be chosen for this.
That's really cool.
Yeah. What kind of reactions do the sailors have when they see these buoys kind of moving into a formation?
Yeah, it's very hard for all of us, let's say, robotic buoys builder, because sometimes sailors think that the buoy is moving, but actually it's the current and they are moving, but they are not used to that, and they always point a finger at the buoys. So it's good, but because we have applications to show that the buoy was not actually moving. But now there are also sailing specific rules to help the use of robotic buoys in general, because if a buoy is just correcting its position because some sailor just drag it away, there are no more, penalties for the ones that is touching it while it's repositioning and stuff like that. So it's changing a bit also the way we sail.
That's really interesting. So the robotic buoy is actually changing the way you sail around the buoy, because if you touch it, because you could move it.
Yeah, they need to stay a bit more far away in general, because we use a normal GPS. We are now trying to think about something more precise. But in general, now the community is very used to that, not only from me, from my competitors as well. So it's something now more normal.
How many buoys do you need for a race? Like how many do you utilize in a normal race?
From four to 9.
Oh, wow.
Wow. There's a lot
Yeah.
of buoys.
Yeah, and then a lot of people was asking me since many years to build something smaller, something also that you could use every day, because you don't want to deploy something that is 1.40 m by 1.25 for a training. So you see here in these images, they are testing our new small buoy for coaching. And this is just 10 kilos. You put it on your rib, you just put it in the water. There is a version without the web application, so you can just push a button and it stays there. Or you can pick the full version with the possibility of remotely control it. It's connected via LTE to our server, so any user can just build courses, and just move everything according to the wind.
Awesome.
Super rad.
This is so cool. I'm so happy you joined us. Thank you. I don't know what time it is where you are right now. I think it might be a little later than it is here.
Hi, Sophie.
Yeah. So thank you for staying up with us. We really appreciate it.
Have a glass of red wine.
Yeah, for everybody.
Oh, yeah. I need that.
Absolutely.
Awesome.
Thank
Thank
you so
you.
much for joining us.
Thank you. Bye-bye.
And you know what's so interesting about that is the way that it does change the game. I mean, if you're rounding the bend there and the buoy, I don't know, I think you need to assess an additional penalty or
Yeah.
something.
I just love how cute the smaller ones are with
I
those
know.
little cones.
Oh, those are great. Okay, next
So-
up. Yeah, go ahead.
So she mentioned at the end there that her systems use 4G LTE to communicate, and that makes range anxiety not a thing. Tyler, you've been out there with the BlueBoat sometimes, and if you're just using the Wi-Fi, especially if you don't have a directional antenna, gets kind of far, maybe something comes between you and it. What do you get?
I've had range anxiety. We've
both
had
It's a
range
serious
anxiety on
condition, yeah.
Saturday.
Yeah, and so earlier this year, Blue Robotics launched the Cellular Modem, so you too, like Valentina, can upgrade your vehicle with 4G connectivity, and then it can actually be driven and controlled from anywhere in the world.
And say goodbye to your range anxiety.
Yeah, let's check it out.
Ever had that nagging feeling? Range anxiety.
Communication lost.
Connection lost again?
When going too far means going offline. What if range anxiety could be history?
Connected. Still connected. Nice. Still connected. I can't believe I'm still connected.
With the BlueBoat cellular modem, you get a reliable connection to your BlueBoat. Stream data in real time, monitor surveys as they happen, and stay fully connected, no matter where the mission takes it.
Still connected.
Kiss range anxiety goodbye.
That's always a fun one.
That's a great little joint. I'm glad we made that.
I liked it. And that is our resident actress and leader.
And boss.
Elisa Miller, she's fantastic. You'll see her throughout this program. She might even stop by the studio for a little bit, so we'll see what happens.
Yes, indeed. Yes, indeed. And of course, if you're out there doing a bathymetric survey with a bunch of kids like we were on Saturday, Tony, that capability is not, would be really nice. A little range anxiety can mess you up, so avert it.
For sure. So I'm excited to introduce our next guest, Rishav Banerjee. He's a great guy, good friend, and he's coming to us all the way from India with the Banergy, and they're doing a lot of interesting search and rescue operations. Hey, Rishav, how's it going?
Hey guys, how's it going?
Excellent.
It's great to see you, Rishav. Where are you calling in from?
I'm calling in from not so sunny Princeton, New Jersey, where I just happened to randomly be this fine afternoon.
Joyzy. Love it. I'm glad we're able to get some Jersey time in. Always a treat.
So, Rishav, you started Banerjee in India, and you guys have been doing various search and rescue operations using Blue Robotics technology, developing some other accessories using our modular components. Let's roll some video and talk about it.
Yeah, for sure. Since December, we started working with the National Disaster Response Force in India. And we started off initially just demonstrating stuff for them. But then once the officers had seen equipment demonstrated, they invited us to real world operations. And this is actually a capsized boat in a distributary of the Ganges River in West Bengal in India. 5 people were trapped in that boat, and this was a recovery operation for that. And yeah, so you can kind of see the target showing up. We had a modified BlueROV2 with a DVL, and what we were trying to do was basically do target localization, find the target, and then figure out what the orientation is going to be, and then put a GPS location down on there so that we can send a dive team. Interesting thing about operating in Indian river systems, very, very low visibility, 15 centimeters of visibility approximately. So most of the work that you're doing it based off of your inertial navigation systems and sonar. So yeah.
Fun.
All right, now what do we have here, Rishav? This is a change of tone.
Yeah.
Definitely, because you got to have fun. So this is something that Tony is a little bit familiar with because in another life, Tony and I tinkered on a project together. And here, this is us in a pool in India testing some DPV systems that we're working on that we call the Banerjee Shark. So we have a single thruster version and a dual thruster version. And again, this is...
You're just chugging along there.
Yeah.
Yeah.
Might be tricky to use in low visibility waters, but they certainly are a lot of fun, and those T500s can really pull you.
Yep, absolutely.
Seems like fun in the pool.
Sometimes it's just about having oomph to go. You know, sometimes you don't need to know. You just need to have the oomph to beat the current, and this really helps.
Absolutely.
Yeah, and then as far as diving goes and the other mission we were discussing previously, I imagine the divers really appreciate not only knowing the coordinate that they need to go for that rescue, but having an idea of how the boat's positioned since they're going to be doing things by feel.
Exactly. And if the wreck is in one piece or not, because that's, when it's 15 centimeters, they're doing everything based off of physical feel.
Mm-hmm.
The river current, they only get about a 40-minute window twice a day based on the tidal patterns and how much the current is going to swing and the water levels are going to swing. So they really need to know where it is, how it's going to be, so that the diver operations are planned out to the T.
That was my next question in terms of operating in rivers. The currents there can be pretty strong, and the Blue Boat has to fight them to hold position, huh?
Oh, definitely. So we employ both the Blue Boat and the ROV. So we have a whole procedure for doing drift diving operations with the ROV.
Wow, look at that. What are these, water buffalo? Coming out of the river there? Oh, that's the Blue Boat scared them out.
It's hurting them.
Amazing.
Yes. Yeah, just, things that you see in Indian environments.
That's incredible. That's incredible. So what river was that?
This is a very small distributary of the Ganges River in West Bengal. It's a huge delta region, so.
It looks wild.
I have 2 questions. So first, what is DPP? I think you've said that a couple of times.
DPV, yeah.
DPV. And then second, how often do you go on search and rescue missions? Like, how often do you guys actually have to go and find people or things?
Right. DPV is a diver propulsion vehicle. So people like Tony and myself who are divers, we like diving. We do not enjoy swimming as much. So the diver propulsion vehicle helps with, getting more miles in underwater in a shorter period of time. And then how often are we going out? Well, we just had the monsoon season, so a little more often than, perhaps we would have liked. But yeah, it's seasonal, but the National Disaster Response Force, they're, a highly professional force, thousands of personnel. So they keep on doing simulated operations and training operations that they keep, inviting us to. And it's always good to get real world experience in the belt.
For sure, there's no substitute for the real world.
Absolutely. Well, Rishav, this has been absolutely amazing, particularly the shots of the wild Indian River tributaries. I really enjoyed that. Thank you so much for joining us on Streamfest.
Thank you very much. Have a good one, guys.
You too.
Thank you so much. And you know what that reminded me of is to refer back to our last transition was Ranger. If he's out there with that blue boat, there's probably not, terrible amount of infrastructure out there. Probably going to need to use your radio antenna, I'm guessing.
Yeah, so we recently launched the mast, which raises your radio antenna from its default position on the blue boat. So it takes it from the deck to just under a meter off of it, and that can double your range. And then if you use a directional antenna at your base station, you can do 1 kilometer, even 2 kilometers with the Yagi that can point right at it.
That's not too shabby.
And you know what I was thinking this whole time?
What's that?
I was like, wow, it's called, like we have a blue boat, but sometimes you need a bluer boat.
That's right.
Yeah. So let's see what that looks like.
Careful with that scientific equipment, Elisa.
Why don't we let Eldon take a turn?
Eldon drives the boat.
I can do more than drive the boat, guys.
Slow ahead, Eldon.
Great. Another victim of our seaweed menace.
Eldon, shut the engine. Bring her aboard.
We're gonna need a bluer boat.
Say hello to 100 centimeters of sheer brilliance.
That's 120 and 35 pounds of her. But I'll tell you, that blue boat ain't half bad. Why don't you start the engine up and follow suit?
Sail into the future with BlueBoat, conquering oceans one seaweed patch at a time.
Wow. That was amazing. And once again, the Academy Award for Best Actress in a Robotics Short Film goes to Elisa Miller.
And we just got to point out that
fantastic.
it is the 50-year anniversary of Jaws this summer.
A classic.
An all-time classic. And in fact, they worked with Woods Hole Oceanographic Institution in the making of that film.
They sure did. Explosive experts helped blow up the robot shark.
That's right, with explosive experts. So anyone that doesn't think Woods Hole is badass, think about that. So what's really cool is we have another amazing guest here. We are winding down. I'm looking at the clock here. We're coming to the end of our hour. Day one is winding down, but we're going to end real strong. Real strong ending here. We got two additional guests here to bring on board. Our first guest is Jason with the University of Rhode Island, and of course, Leiv with JM Robotics. JM Robotics is one of our favorite marine technology companies here at Blue Robotics, and Leiv, I mean, we are live, and we have Leiv.
Yeah, we are very happy to be here.
Welcome to Streamfest.
Thank you so much. What an intro. We're so glad to be here. Thank you so much.
Well, we have some amazing footage that we're excited to dive into. I believe we're going to be exploring a shipwreck in this one. Let's dive into the stream. And Jason, there you are. Are you ready for this, Jason?
How are you guys? This is Rhodey.
Really?
Rhodey was in the lab and was lonely, so decided to join us on the
an additional guest. We love it.
Yeah.
What a beautiful bottle. I love the yellow.
It's a great color. Okay, so here we are. We got the stream up. Jason, why don't you tell us a little bit about what we're looking at here?
Sure. So this was a project in Lake Ontario funded by NOAA to explore shipwrecks in the eastern half of Lake Ontario, which had just recently been designated a National Marine Sanctuary. So we partnered with JM Robotics to build a custom vehicle. You can see Rhodey behind me, right? The key technology was the Voyus stereo camera that we integrated into the skid. And we used Rhodey over the course of 2 weeks to explore wrecks in the lake. Some of these were known and poorly documented. Others we discovered ourselves, mapping at night and then diving the ROV. Deepest depth, like 680 feet. So, you know, nearly the pushing the limits of the vehicle, especially for something like this where we were, you know, hand controlling the tether off the back of a large research ship. We were on the Lake Guardian, which is the Environmental Protection Agency's largest research ship in the Great Lakes.
Wow.
But we were really successful. In the end, we had 17 shipwrecks documented. We ended up, the farmer's daughter, this wreck right here was shown or highlighted in the New York Times in a Tuesday Science Edition article that we were really excited about, but all enabled by the partnership with JM Robotics and kind of the BlueROV backbone of this vehicle.
Cool. Can you tell us a little bit more about that partnership, Leiv and Jason? How did that come to be?
Yeah. So we were over in Houston on together with Chevron to showcase our technology because we're doing some work with them as well. And we kind of linked up with Jason, and he came across from Rhode Island all the way over to Houston to kind of see the ROV live and see how it behaved. And we had consecutively a lot of meetings after this, just figuring out what would be the right sensor package, what would be kind of in terms of getting the right positioning equipment on there, getting an appropriate sonar, the DVLs, laser, scaling lasers and all of that. So it was a very back and forth discussion on finding the right fit. And as you know, we do a lot of these custom projects and manufacturing all of the parts in Kristiansund made it easy for us to kind of build a package around this, build an ROV around the sensor package, really.
Cool. And that sensor package you mentioned was a stereo camera. One of the amazing things when you have two parallel cameras, just like our eyes, is that it gets a 3D view of the world where everything's to scale and you can track your motion through it. So it sounds like you were able to create 3D models of up to 17 wrecks with it.
Yeah, Jason, you can comment on that.
Yeah, sure. Well, I think the footage that's rolling now is from the camera on the left is the Voyus Discovery camera footage, and then on the right is a recording of the screen of the live 3D modeling. This is based on vSLAM. This is a software package from Voyis. And so the key difference using this software suite allowed us to know if we imaged a part of the wreck or we didn't, because previously doing photogrammetry like this, the worst case scenario is you get the whole data set home and you realize that you forgot a part of the wreck because you didn't keep good notes.
It's like painting your house.
You missed a spot.
You don't want to miss a spot.
Yeah, exactly. And so seeing the model built live was a key enabler to make sure that we got our money's worth while we were on the bottom. And Leiv and the team at JM integrated a fiber optic umbilical to let the data flow at full capacity from vehicle to topside. That really enabled the 3D modeling to happen in real time. Previously on a copper umbilical, you couldn't get that enough data out of the vehicle to enable that. So the partnership and knowing those requirements allowed the JM team to really customize the build and really push the technology limit on what they were providing to us. And it just turned out great.
How long does this take? This seems like, getting that imagery, doing all of that, it seems like it would take a long time.
It was, we were on each rec site. We did about 2 recs a day. So we were there maybe 4 to 6 hours on each site. But the cool thing is this was a student-led project. So students from the University of Rhode Island were piloting the ROV. So at the beginning of the expedition, things took a lot longer than they did at the end as the students became more precise and we had, a rhythm to operations. But by the end, the data from the student pilots was just as good as the experienced professional pilots that we had out with us coaching them.
Yeah. Well, I imagine just like those students have probably played some video games, they get better with some practice and can really navigate with nice, smooth motion.
Well, hold on. And I understand that you guys discovered some new wrecks while you were out there. What wrecks did you discover?
We did. So the wild thing about shipwrecks in the lake is a lot of them are unidentified. So the one prominent story is in the middle of the night we're mapping and we have a lead mapping technician and a student watching the mapping screens. And sure enough, the lead mapping tech is in the galley getting a cup of coffee or something. And the student sees like this blip on the multi-beam sonar and immediately starts like tearing through the ship, waking everybody up because it was distinctly a shipwreck.
Wow.
And when we were the next day, we all woke up to these text messages of the shipwreck find. We end up going back to the site and diving, and it's this 3-masted sailing vessel that sat beautifully on the seabed, like it was placed there delicately. You couldn't tell that there was a collision or how it could have been came to rest on the seabed. But it was an original find from our team led by a student, right? They were the discoverer of this shipwreck I think Susanna is going into her junior year here at URI she's an ocean engineering student. And so that's on her resume now, right? She
I'm discovering.
in Lake Ontario, which was just wild. Yeah, here's the team in the image. And the cool thing about a couple of the faces in that team were members of the JM Robotics crew. They came and sailed with us on the expedition. The partnership between us, I don't think there's much air between our ROV team and the JM team. We talk regularly, we share what we learn. They come out on our projects. Like, it's just a really fruitful partnership.
It really looks like it. And thank you both so much for sharing with us today on StreamFest. What a great final guest for day 1. Thank you both for joining us.
Our pleasure.
Pleasure to be here.
Thank you, guys.
Absolutely. Wow. I am left satiated, but wanting more. I think I could do 2 more days of this. How do you guys feel?
Same. That was super cool. I mean, what a way to end it. I mean, as somebody who felt like they were in grad school for so long doing similar work, it's really cool to hear the empowerment of students to get into this work, to work with the technology, and to find a shipwreck. Like, come on.
I mean,
where do you go from there?
For me, it doesn't get any cooler than that. Tony, have you found any shipwrecks?
I don't think I have. I've been to ones that were previously known.
We should do that
wrecks.
together.
We should find a shipwreck.
Go out and find a shipwreck, the 3 of us.
I was like that.
What's exciting is, the opportunities to use equipment to find shipwrecks like that used to be limited to, people with budgets like Bob Ballard and the Nautilus. And, you're driving ROVs the size of school buses that cost hundreds, if not millions of dollars, hundreds of thousands. Yeah. And now, you can get 1 or 2 person portable vehicles that, students can learn to operate as good as the experts in just a couple days.
How about that? And that's really cool. I mean, I got to say that's super cool.
Super cool. We have a whole bunch more to come though. This is not the end. This is day one. We have 2 more days. I'm so excited. That was good. That was like a good little just the first taste of what's to come for the rest of the week.
Absolutely.
So thank you to all of our guests for being here. As a reminder, this is a recorded broadcast. So if you missed it, if you're sleeping, you can just tune in later, like when the sun comes out, because I know we have some people who will be doing that. Everybody who was involved in the technical broadcasting parts of today.
Yeah, can we put the camera on the crew? I think that'd be cool.
Give us a little zoom.
Let's turn it around.
Give us a little zoom.
We'd actually like to
look at the production team. This was a big operation here. So thank you all to everyone who worked on this, and please tune in again tomorrow.
Tomorrow, same time, same place, 12 p.m. Pacific Daylight Time.
High noon.
And yeah, we'll see you then.
See you tomorrow.
Keep putting those questions in the chat or comments, and we'll try and get to them tomorrow.
Absolutely.